Everybody, welcome back to the workshop. We're going to continue on with the milling machine. The next steps that we need to do is verify the machine, the table for tram. It's supposed to be trammed in from the factory, from Precision Matthews, but before I actually do any test cuts, I want to confirm that and use this tool that I purchased. It should mount to the collar on the spindle, and hopefully I can run the table back and forth and we can verify that table for tram. But before we get to that, I wanted to show you just a few starting tools that I purchased just to get started. I don't want to go crazy and buy a bunch of stuff that I may or may not use. I gotta learn the machine and learn all of its ins and outs before I decide what I really want. I know for my cutters I'm going to want to get carbide. It'll just last longer, but for now I went ahead and purchased some high-speed steel. We'll get to that in a second. But at the moment, what I have is this. This is from Anytime Tools. I got it on Amazon, and it's got Noga style rotational adjustments, so you can, tram in the lathe table. So I'm going to use this. Once you tighten that up, it stays. This should be able to mount up here, and then I can mount this and we can go back and forth. So that's what I'm going to use for that. This will mount into here so that we can make sure that's not going to move, and we're just going to use the dial indicator that I have. Let's set that aside, get this out of the way. This is a drawbar. It's an R8 drawbar. I haven't mounted any of the collets or the collet chucks that I have, but I will show you what I got. I purchased this again to start with because I thought this may make the most sense for me. What this is an ER40 collet chuck. It comes with a wrench, and there is the R8. And the drawbar should thread down in here just nicely. I think it's 7/16 20. That's what I wanted to test to make sure that goes in there. And then that will draw it up into draw it up into the collet there, the R8 spindle. Then, of course, it's ER40, and I can put my collets in here for the appropriate size for the end mills or whatever else that I'm working on. I went ahead, I'm a fan of the bearing style collet nuts. This one is the same dimensions, but I went ahead and purchased one of these because I believe that they'll hold up longer than the non-bearing style, because it puts a little less wear on your collets. When it gets up there, it'll spin this bearing. But let's just get that on there because this is what I'm going to use. Clean off the excess oil. But anyway, if you've not seen one of those, you can see how that bearing in there spins. So when you're tightening down your collet, the collet will stop, or the actual collet will stop spinning, and it won't scratch up or put unnecessary stress on your collets. So let's put this in here. Make sure that's going to fit. Sure enough, it does. So I've got this to go with some testing that we'll be doing. Let me put some of this stuff away. I did buy this. I don't know if I really should have bought this or not, but I thought someday I'm going to wish I had. I didn't need another Jacobs chuck necessarily, but I needed this. I should have just bought this, I think. But this is an R8 spindle to, I forget the Morse taper. It's an R8 shank. Anyway, it's your standard Jacobs chuck, but I bought a Jacobs chuck for this as well, figuring I'm probably going to want to use a Jacobs style chuck for some operations, whether it be drilling, tapping, who knows. Comes with a chuck key. But I do have that. Should probably go ahead and just get this out and assembled. A little greasy, but that out of there. Let's go ahead and just put this stuff together so it's ready to use. I'm not going to send it back. Get this out. It's yellow. I don't know if it's grease or cosmoline. More cosmoline. This isn't all frozen up though and hard like the lathe table had, or mill table, sorry. I've had a lathe for so long, I keep saying lathe with this. Okay. So that's ready to go as well. Might as well just get it all out. Clean some of this mess up. I've had it here on my bench, but I wanted to share with you what I got. This is my initial tooling just for testing. I'm going to quickly buy some more stuff. I know I'm going to need some clamps and an actual mill vise and just some other things, but for now, I just wanted to get some things so that I could get started with this milling machine. So that's the collet chuck and the drill chuck. Let's move on to some edge finders. If you looked in a previous video, I got a Brown and Sharp. This is an edge finder from Dave. He had an extra one, and he sent this my way in a gift package, care package, so to speak. There'll be a video on that, but this is nice. It moves very well. I believe this one's 3/8, so I'm glad to have that. So I'll be able to, when I'm working with some materials, I can find the center point and use my DRO and just start learning how to use these tools. In addition to that, I went ahead and purchased, I don't know if I needed to, but I purchased a Mitsui 1/2" edge finder as well. Show you that. I didn't know if I'd need that, but it'll give me some options with collets. If I already have a 1/2" collet in there, I can just put this in. Anyway, so I got a couple edge finders to get started with. I've got some center bits, and again, this was early on. David sent an extra high-speed steel end mill that he had. This is not the center cut, so I wouldn't be able to just go down without having a hole pre-drilled first. But most of the end mills that I purchased, I bought a crappy set for, I think it was 16 bucks. Like I said, I just wanted to be able to cut some aluminum day one when I get this mill and I'm ready. So I knew I'd need some cutters of some end mills of some type. So I have an assortment. They go from, large, and these are high-speed steel. Again, same type of thing. I would have to pre-drill if I wanted to plunge cut with this. Let's say this would be good for maybe a cap head type bolt fastener that I wanted to be below the surface finish of something that I'm working on. I don't think all of these, it's kind of weird. I think some of these are inconsistent in exactly what they are. They are all high-speed steel. I don't expect them to last long. I already know that. There's one that is not a center. I thought that one looks like it actually is a centering type bit. I don't know if there's a marking on here that would indicate that. If you can read that, you let me know. But anyway, so I have end mills to get started. Finally, I wanted to share, I don't have a proper vise yet. I'm dabbling whether I want to go 4" or 5". I know they get big. I don't want to lose a whole lot of height on my table. So I think I'm going to go with a 4" vise to start with. I think it'll be fine. This is a 4" vise, but it's a drill press vise. This is super cheap. Came from Menards. There's no precision or accuracy, but I think for my test cuts, this is gonna do. I'll be able to mount this piece in here and just do some centering and some testing and just get started with something. So I think I have everything I need to really get started once I get this thing trammed in, and then we can actually turn it on and make the first chips out of this. So with that, I just want to share those tools. Let's get over here to the milling machine and get started tramming it in or verifying that it's trammed. I hope it's just trammed right in. That would be amazing. All right, everybody, welcome back. We are not really going to tram the machine in so much as verify its tram. It's supposed to have come trammed from the factory, and I don't expect everything to be spot on. You know, you see A-Bomb do this kind of stuff, and all of his stuff is just perfect all the way across. This thing's mounted on a wooden table. It's not bolted to a concrete floor. There's no metal stand. There's going to be flex. There's going to be give and take to all of this equipment. So what I'm shooting for is just, you know, as close as I can get it, especially during this initial learning phase that I'm going to be in, trying to understand the machine, the concepts. Even though a lot of the concepts from the lathe kind of apply to this, it's a different machine. It's different techniques, different ways to tram things in. The headstock moves back and forth. You know, the table moves front to back, left to right, and all that. So, you know, I just need to learn what's important and what's not. I've been talking to a friend, and he has been helping me try to stop focusing on things that don't matter so much and focus on the things that do matter. So with that, what I've been doing is working on just verifying the tram. So I've got my dial indicator mounted to my spindle. I have it set to 0, and I'm going to sweep it. It's a 10-inch sweep, so 5 inches from the center of the spindle this way, and it'll be 5 inches this. So it's a 10-inch sweep, and we'll see just how off we are from the tilt of the head. So what I've been doing, this is a setup. I get that set to 0, and I'll bring you in here closer in a second, but this is what I'm doing. I'm using the find adjustment. I set it to 0, and then I sweep carefully. I don't want to move the headstock or anything else. So I sweep this around, making sure it doesn't hit anything. Clears everything. I bring it around, and we're spot on, 0, 0. I was getting maybe a half a thou or 5/10 off, but I tightened everything down, and it's reading very accurate. I'm going to pause you over here. I'm going to bring you in for a close-up shot with my phone. I just want to I want to show you what I'm doing so you can just see what this is reading. All right, let's get you set up here so you can see this. There you go. Okay, so I've got you in a tripod because I'm trying to avoid the shaky cams. I want to use the phone so I can get you some close-up shots, but as you can see, we are on the 0. I'm going to spin it around to the other side, and I'll bring you around so you can see that there's no trickery going on here. But what we're doing, we've got it set to 0. I'm not touching the headstock or anything. I'm just going to rotate the spindle bore or the spindle carefully, making sure it doesn't hit anything. And I'm going to bring you around to this side. And show you what we're at. So we are at 0. So I would say they've got it trammed in very well from the factory, and I'm quite happy with that. So I just wanted to get you a close-up and show you that that's how it came from the factory. I'm going to hold the camera this time. we'll just rotate it back slowly. Try not to bump it in any way. Bring that back. See where we are. And as you can see, we are still right on the zero, a little bit off, but I did touch this up here. And if you bump any of this stuff, it comes out of there. Watch, if I just tap that. I mean, so you got to be real careful when you're spinning it. But I'm quite happy with that. And that means that we can move on to the next steps, which are mounting that crappy vise and doing some test cuts. All right, so we verified tram, and I think I said I was ready to mount the vise, but we're not going to do that yet. The next thing that I haven't done, and I want to get mounted in here, is my collet chuck, my R8 collet chuck. Plan on using that. I'm going to see how it goes versus buying a set of R8s, but I do have a nice holder over here for them. It's underneath the DRO. I may go ahead and pick up a set of those collets anyway, but for now, I want to get this collet chuck mounted up. And this is my R8. And this will be the first time I've used this drawbar and went through this process. So let's get this nut off of here. Set that aside. There's my collet chuck. We need to take off this plastic cap. Here is my drawbar. As I said, this is the first time I've used this, so we'll see how it goes. And there it is. Now, we need to probably raise this up in order to get this in there. So let's go ahead and do that. We're just going to use the wheel back here. Make sure we don't have anything locked. We're good. I told you all we were going to be learning together. All right, I've got this thing figured out. The drawbar doesn't go on top of this flange nut or this spacer nut that's already pre-installed. You got to put this drawbar in first, and then it gets captured by this threaded nut on top. It goes up here. So that's why I was trying to install the arbors, and I didn't have enough length, and I'm like, I got the wrong size drawbar. I'm like, that can't be right. So this needs to be installed first. Then this top nut will go on here. Then we can tighten that stuff down. So let's do that. All right, now we've got that tightened down. And there's my drawbar. It's got just enough play in it, so if you're loosening up, you need to wrap on that. It will loosen up your arbor. Well, let's see if we can get this R8 collet chuck installed now. There we go. Give her a wiggle until you get it seated to go up in there. Come on. Let's see. Just want to get that started right. I think that's it. Take out this trusty wrench. There we go. And that should draw it up nicely. I'll just do it like this. There we go. So now I've got that installed. You can already see the real estate that these take up. A lot of people talk about that. That's why those R8 collets themselves, they're really fairly flush to your actual spindle. Save a lot of space. I may do that someday, but for now I can get started with a lot more variety sizes if I just went with this. So that's the direction I went. I want to get this put back on. Took it off while I was trying to figure out what I was doing wrong. We're not ready to do any cutting yet, but I do want to go ahead and mount an end mill using this collet chuck and just turn it on and get it to spin and make sure that that's all cool now that we've got something installed. So I got the collet mounted. Now it's time to put the collet chuck in. I'm going to use this is a 3/8. It's a 5/16 end mill, but it's a 3/8 shaft, shank, whatever you want to call it. And I've got my 3/8 ER40 collet right there. The other thing I have is my collet nut. Let's get this snapped in here. And we want to get this started. Set down that end mill. We can go ahead and slide that up there. I'm going to slide it all the way up, right about there. So the right way to do that is probably support that and tighten this down. Again, this is just a spin test. Make sure I've got everything going. Make sure it's nice and ready to fire up. I've got it set to forward. We're going to turn it on. And we're ready to go. Go ahead and turn that down. Let's spin her up. It sure looks like it's running pretty darn true. There's 500 RPMs if you can see that up here. That'd be kind of hard to see. Pretty quiet. I'm excited. And if we open this, it should shut her down. I'm not sure just how useful that's going to be. It doesn't clear the cutting material, just the spinning portion here. Anyway, not enough about that. There we go, success. So we now have this thing Tram kind of confirmed, verified that it's really close enough for my use. And now we have an arbor installed, and I think the next thing to do is install that vise that I have for my drill press. It's going to be temporary, and I just want to use it to do my first test chips. Later I'm going to be getting what I hope is a better vise, but for now I just want to get that installed, and we'll do some test cuts. So this thing is not true. It's not made for this at all. I totally understand that. Please don't hammer me for using this thing. Again, I'm just testing something. Just want to do some test cuts. So I'm going to use this for today, but very soon I'll be getting an actual vise. I do have some T-nuts that came with it. So we'll see. Let's back this out. And we'll just get this shored up. It's not going to be level, it's not going to be square. I'm not going for any sort of precision whatsoever. I'm just going for some test cuts. And I need something to hold down some material. I don't have any locking. I don't have any locking or clamps, kits, or any of that kind of stuff yet. So this is what we're going to use just for today. So I just want to cut some material and then bring this video to a close. And this is really going to complete my initial setup, test cuts, you know, checking for tram, going through the book, making sure I've got everything the way it should be, all the way through doing some test cuts. So just got to get these ran down. So that's secured. Like I said, this is not precision or anything at all. Let's wind this out. Let's see the first material that we have to test with. I got this piece of nylon. It's a little bit lower than I wanted it to be to raise that up. It should hold, I hope. Yeah. Let's wind that back in. Again, this is just a piece of nylon. Just tighten that down. There we go. Alright, so what I want to do is just take off a little bit on this side and we'll see what we can do. Bring this down. Bring it over. There we go. I'm going to bring it back up. And what we'll do is bring this across. It's pretty hefty. It's nylon, so it doesn't matter, but what we'll do is bring it down. I think what I'm going to do is turn the DRO on, and I'm just going to do some cuts kind of where it is now. That would be my x-axis. I'm going to call that 0. The y-axis, Z is what I'm going for here. What we'll do is go ahead and do some cuts, and then I'll set that to 0, and then I'll go down a little bit based off of my DRO. Let's get this going. Doing 1,000 RPM, but again, this is nylon. So let's call that our 0. There's a 30 thou cut. Take it slow. I gotta remember I'm coming across a tool bit. I don't want to break it or snap it. An end mill. And then I want to come over on the y-axis. And we'll go over another 50 thou. Maybe we'll do 100 thou. Yeah, we'll do 100 thou. Because we're doing a facing operation with this little end mill. This thing runs very quiet. Quite happy with that. And then finally we'll go another 100 thou. 250, again I'm using the DRO. Learning how to get used to this new equipment. And we'll bring her back across. Okay. Go ahead and stop that. And wipe off some of those chips. Plastic. Nylon. Let's take that out of there. There we go. We faced it off. First cuts on the mill. I can tell this is going to be fun. Alright, so I've got more of this to test with. I'm going to use this and just play around. But I do want to go one more test cut with something a little more difficult or a little more challenging. Let's get, I don't know if I'm going to need that or not, but let's loosen this up because I need a wider space here. I may have to use a different material, but for now I'm going to try this one. See if it fits. Problem's going to be these bolts, but we'll see. I got this chunk of aluminum. Actually, that will fit. Again, it's too low. I'm going to turn it down. I mean, that is 1,000. Let's turn her down to, I don't know, 600 RPM. Okay, so I'm going to call that axis my Z. We'll clear that. The X and Y, it doesn't matter for this. Alright, let's get on with cutting some aluminum. I'm going to bring that down. I'm going to use my quill again. Fine adjustment on the quill. And we'll bring it down. Let's do a 10 thou depth of cut. I'm going to take it slow. I don't know if it's too slow or my speeds are too slow or if I should have some lubricant. I'll turn it up. I did. So I'm going to move her over about 10 thou, and then we'll keep going. Okay. Now let's bring her back. Okay. Now let's bring her back. That is so smooth, super, super smooth. Very cool. First chips in aluminum. All right, guys, we're gonna do a little bit more, one more pass on this, and we're gonna call this video complete. First test chips, cutting 10 thou of aluminum off. This is super smooth. Quite happy with how this is turning out. Let's bring this over right about there, and let's make one more pass across, and we'll call this video complete. First test chips. I'm using some lubricant so I don't get any galling. It's high-speed steel. Let's get this up to 800. I had it about 825. There's 825. All right, let's do one final pass. Turn all that off. Let's raise the quill up so it's out of harm's way. Let's also bring that up. All right, we have made our first test chips. Let's back this out. Let's get our workpiece out of here. I don't want to bang into that end mill. I think that's good. Should be able to loosen this. Now, I have to figure out chip management and all that. It's different with this than it is on the lathe. All right, everybody, let's close this video out. What you just saw was me finishing up the setup of the mill, verifying its tram, and it's pretty spot on. It's good enough for me at the moment anyway while I continue to learn. We got our Chuck Arbor R8 ER collet installed, put an end mill in there, and we did some first test chips. First thing I did was some nylon. That cut very well. I didn't cut a lot, just messing around. And the second thing was this aluminum billet. It's very smooth. It's pretty cool to be able to make these kinds of cuts. I don't know how well that'll show up, but pretty happy with that. First test chips, aluminum and nylon. Anyway, thanks for watching. Stick with me. There's going to be a whole lot more with this mill. And if you haven't subscribed, please do. Helps out the channel. I'm trying to grow. And otherwise, thanks for watching, and I hope to see you on the next one.